So hopefully you can see my Google Doc. I think you can.
I can. Yep. All good.
Sweet. Yeah, so I think that was the biggest thing is like reaching students. So for me as a teacher, like to quote my friend Alice Keeler, like I don't teach math, I teach students. And so I want to teach these students math, but the only way that I'm going to be able to connect to them and teach to them is make a connection. And the biggest way to break that connection is to not value their communication piece. And when I look back at my first years as a teacher, there was so many times I would like tell a student, we would talk about a question, I'd say, how do you do this? They would verbally tell me, I'd be like, great, write that down on the piece of paper and then turn it in, and then I'll give you credit for that. So really, I was only validating one method of communication. If they conformed to the way that I wanted them to, then I would say, oh, I value your information. And so that I think is the reason I talk to so many people about their math experience on planes, or in the real world. And there's so many times when people just had a negative math experience, not just not positive, like fully negative. And almost always it was like come to some experience. So they had a teacher and they'd say, I always got the right answer, but the teacher never gave me credit because I didn't do it their way. And so I think that's the narrative that we need to get to switch and flip here is that we can engage students by validating their communication in all forms and all methods. Now, granted, for me as a teacher, I always had like this one, not non-negotiable, but one thing is I wanted it to be digital. I wanted my students to use the digital format because there's so many benefits. And sometimes like with the accessibility realm, it's required for that student to use that accessibility. But I think that we want to give them the choice to choose which method they want to communicate. So that's what we did with Equatio. We built it on these UDL input tools. So the student should be able to choose how they want to create and consume their math. And that I think is really a powerful piece of engagement. So we have all of these. So it's a Chrome extension. So if you click on the little button, it pops open the Chrome extension. And from the input tools, we have the equation editor, which is really great. I think I saw Greg doing the speech input. So I think, not sure how far he got with those. But we have the equation editor, which I'll demo pretty heavily. The LaTeX editor, which I hope nobody ever has to use. We're trying to phase out LaTeX from being a requirement. It's just a typesetting language that if you were a university professor trying to publish a peer-reviewed journal, you would need to submit it in tech file. But we shouldn't need to do that if you're a fourth grader trying to talk about your sums. We integrate fully into Desmos. We have a full Desmos suite integrated directly into here, so you can use our input methods and then use the graphing. I love Desmos. They shifted the way I taught, and they still do. They're an amazing company, really impacting students' lives. We have a handwriting recognition. So many times that we say that handwriting is the best way to do math. I had so many people who would tell me, "Oh, we don't need to use that computer. Pen and paper is the best way to do math," and I would disagree. I would say pen and paper might be the best way for some, but not for all. And it might be a hindrance to some, specifically those that have limited physical mobility. They can't do the handwriting. They need to impact other ways. But if you did want to handwrite, we can do that and recognize that. The speech input is, I saw Greg demoing there. So if you want to speak your math, it's one of the fluencies that we try to have from a procedural standpoint as well. Like so many times I would have a student who would write something down on the whiteboard or the small whiteboard at their desk working in groups or on a piece of paper, and I'd ask them to explain it. And that's I always, I'm not a very funny person, but I enjoyed making jokes because I had a legally mandated audience that some also really wanted to laugh because they wanted to make me feel bad, not make me feel bad about my bad jokes. But I would always say that with if you can't communicate your math, did you really do it? That's the heart of it. It's a communication tool. And so that verbal piece to do that speech input and then have it be read back to us is a great circular way to cement that understanding between a verbal fluency and the notational competencies that we are working with. Because I always talk about there's two different pieces. There's the verbal piece or the terminology, and then the notational piece or like the written component. Also, so many times I had students who had impeccable handwriting, great notebook, great organization. That's the antithesis of my experience with paper and pencil. I was the student that would lose it sometimes or just didn't like it. But Equatio Mobile allows us to take a picture of the physical math that you create, make it digital, make it accessible, make it editable. A really great way to organize your information. If you're working on a whiteboard or a chalkboard or just a different piece of physical math, you can take a picture of it, bring it into our digital realm. And it's also accessible and editable. Super cool. And then the Equatio Math Space gives us, I think about it as a digital whiteboard on steroids built to do STEM content. And then the last bit is our screenshot reader, which you can, if it's on the screen, we can screenshot it, whether it's handwritten or typed, and read the math out, but also make it editable out of that as well. So that is really the big piece, is accessibility, editability, to really engage the student to communicate and create and consume the math in the method that they prefer. So that's kind of what we're approaching for, is trying to be platform agnostic, device agnostic, and almost method agnostic. Like no matter which way you want to do your math, we should be able to do that. And Equatio could be that digital bridge. So if Greg wants to speak his math, that's awesome. I want it to be digital. He can turn that into me, and I can then, as a teacher, consume it in the method I prefer once it's digital. So I think about it as being almost like a Google Translate for digital math. So let's just do a quick demo about that. So I think another piece that is a hindrance to students is palette-based editors. So if you go into like Google's default equation editor, it's the traditional palette-based editor, which you can see here. It's great for me as a math teacher. I know what the square root symbol looks like. So I know, oh, there's a square root symbol. I can identify that. And then here it's even more complicated, so adding levels of complexity. If I want to make a square root symbol, I need to know to transfer that knowledge that if I click the square root of x button, it'll make just a square root symbol, and I can make the square root of 4. And that was the real epiphany that I had for me when I was trying to have my students. I was working with 7th graders, and we were talking about roots. I was trying to teach them square roots. They were all excited. They got these shiny new Chromebooks. They were really, really engaged, which for me was a new thing, having like all of my students excited about math on the first day. Usually half of them walked in not even knowing who I am, but also, already not liking me because they didn't like math. And I realized that process was a problem. I wrote on the board square root, so they were all clickety-clacking on their keyboard, taking notes, square roots, and then I put the square root of symbol up there. And so literally the keyboards went silent. I was looking around, everybody had crinkled up faces, really confused. And then out of the corner of my ear, I heard a YouTube video start. Here's how you type a square root, and which was awesome. Like my students were researching how to make a square root symbol. And that was great because I was trying to teach them how to learn. But then I realized that was a negative experience because some kids had checked out, but even more so that they didn't realize how to do that. So that was a huge hindrance. So now what all they need to do is they don't need to know, especially if I'm teaching them a concept, how are they going to know the notational bit to be able to represent their thoughts and learn? So there's a mathematical prerequisite, and then also there's a cognitive load. They need to pre-plan everything in these palette-based editors, because if I want to make a radical and a square root, in the numerator or fraction, do I make the fraction first? Do I make the square root first? How does that work? I liken it to, you need to pre-plan your entire paragraph before you write it, and you can't edit afterwards because it ruins everything. And that's similar to the experience of using a palette-based equation editor. So we wanted to eliminate the palette-based equation editor and just make it most intuitive and delightful and fun, which are adjectives never describing an equation editor. So really low bar here, but all I can do is just start typing square roots. That's great. If I know the terminology, I can then connect the notation to it. And I'd be like, yeah, I mean that. And then I can make that in there. And I hit square root, I insert the maths, and it puts that directly into my document. One of the good parts there is I can resize that. I can do whatever I need to. But now it's actually automatically accessible as well. So if I go through that, it'll be able to read that aloud. So that's a really cool bit. And I can directly edit it, and it brings it up into the toolbar, and then I can I can change those up if I want to make it square root of 9, and then I can reinsert that. So I think that's a really cool way for a workflow for I can create some problems. I can send them to my students. They can hear it be read aloud to them, and then they can also continue to start to work with that and edit with that. So it's a twofold component with the equation editor. That prediction really makes it more intuitive for them to be able to represent their thoughts. And they might know what the phrase is, but not the notation. So that can help connect those two bits to help them learn that concept, but also it just really makes it easier for a workflow management style. So I feel like it's a twofold thing. It helps them connect notation to terminology, which is at the heart of the learning, and it also makes it easier to facilitate them to communicate what their thought process is. So another thing here, like I can start just typing 3x minus 14 equals 10. So for me, like that makes it really easy. If I have to do the minus sign or the plus sign, it's easier for me to type min, enter, with that prediction versus stretching with my pinky to hit the minus key, or especially if I want to do a plus, it's a difficult keystroke to do. And I have I have adult sized hands, so it's even harder for younger students to be able to do that. So that's another way that I can just directly insert those bits into my Google Doc or Google Slide or whatever I want, and it should make it easily to communicate that. You can see that accessibility, it says 3x minus 14 equals 10. So it's a great way for them to represent those thoughts and to hear that. This says the square root of 9. So then if they have read and write or some other screen reader that comes by, and it can then ingest that and be able to read that for them so they can hear it be read aloud. So that's a really great way. I have my headphones on, and I don't think that you'll be able to hear that, so I won't play it, but it would read that as it should say from an accessibility standpoint. So that, I think, is a really cool way to connect the visual component and the verbal component to be able to hear it and help with that fluency and that communication. I think it's really great for students. And so I can start with this and I can edit it. And one of my favorite things now is we have some keyboard shortcuts. So as a teacher, my workflow would be like, I want them to write down the next step. I want them to add 14 to both sides. And so if I just hit Shift Enter, I get a new line and I can just start continuing to write. But even better, if I hit Shift Control Enter, it copies down the work to the next line. And so many times my students would make errors or mistakes in transcription. They would write the problem from one step, or even before that, writing the problem down, copying it from the book or the whiteboard down to a piece of paper. They would make a mistake, and then they would work from that mistake, and they would get the wrong answer because they copied the problem down incorrectly. Transcription error, I'd say like 5 to 10% of the time, if a student missed the problem, they literally just copied it down incorrectly. And with younger students, especially who are working on writing their numbers and writing that organizational bit, transcribing from one step to the next is an extra cognitive load because they're doing this physical replacement and transcribing, whereas here we can just emphasize. I had a big poster in my classroom that says equality equals interchangeability, which was a pun, but I was just say if two things are equal, they're interchangeable, you can replace them. And so here, what I would want to do, I want to say, we'll do that plus 14, and then I can literally just copy that and paste it over here and say, just do the plus 14. And for me, that gives my students so much extra steps in there. And then they would say they would delete this or turn that into, what they would turn that into a plus 0 or something. And so they can just literally communicate much, much more here. I accidentally slid that over. Sorry about that. I'll have to restart that bit because I never inserted it. Another thing about that discoverability is it says here, like the first time it pops up, it says like, hey, there's some editable equatio editable stuff in here, and I can just click edit on there. So it's really helpful to tell me like, hey, you have some math that you can do. Go ahead and do it here. So I can just do plus 14, copy that, and then paste it, which is a really powerful component for the math bit there. That's just being able to replace that technology. Makes it more helpful. And then I can also see a lot more of my students' work. If this is on a piece of paper, they probably wouldn't write this step down very much because they would say, well, you know what I meant over there, because they didn't want to write down the extra steps. And here's where some of the fun part goes. When they might say 3x over 24, they can literally write over, and it puts the preceding term in the numerator, over 3. And it is really exactly what they're thinking of. They can also just like, if I wanted to do that, I can highlight something and hit the slash key, which is the typical division key on the keyboard, and it'll put whatever was highlighted in the numerator as well. So I can just copy that down, and then I can literally highlight what I want and replace it. So it's a much more representative bit about what I'm doing here in my math components. And so that, for me, to get that amount of work from a student in handwriting would be a really laborious process, and they'd be prone to a lot of mistakes. And so from there, I can see that process is much, much more, technology makes that a much easier process. And the cool part is that's editable as well. So if they made a mistake, they can come back here quite easily, which is not that they couldn't do it on paper and pencil, but they can just, maybe they wanted to replace a number, they can do that much easier than rewriting the whole entire component. So I think that's a really powerful way to work on that math. To be able to do that. You can even read that aloud as well. If I would have that read aloud, I would read it out. It's as having all of the steps in there. So that is a really cool process to be able to see all of the math and have that be heard from an accessibility standpoint. Just to belabor the point about LaTeX, so if I edit that to bring it back in, it'll show me how I can make that with our prediction, which is pretty intuitive. And then LaTeX, you would have to know that all of these different commands, not super fun. I would not recommend anyone having to learn that. If you know it, awesome. If you don't, you shouldn't have to learn that to be able to recommend your thoughts. I'll pop over here in a second from that Desmos graph bit, but I wanted to show a little bit about that handwriting recognition first. So you could do the handwriting. I'm here on my Mac, so I'm just using my touchpad. But I think this is a really cool way for students who can also acquire that understanding. Maybe they have no idea what this math part is, so they can just copy it down from the board or copy it down from somewhere they've seen it, and then we'll typeset that. And then the great part is once we insert that, it goes into the document and then it's accessible and it can be read back aloud. So it'll say to them that that's 3x squared over 4. A really great way for the students to be able to understand that terminology and understand what that math looks like from just the notational component. So they can have maybe the notational and they can learn that terminology piece with that. So it's a really great way to augment their understanding or cement the learning between those two bits. Whereas previously, you'd need to know both of those, terminology and the notation, to be able to represent it. You can't just go with one bit. So you can actually learn as you're representing it digitally. And then conversely, if they, as Greg was saying, maybe you know the terminology, but you don't know what the notation is. Had a very profound moment sitting in a Starbucks and watching a girl be tutored, and the tutor kept saying 3 squared, and the girl wrote 32 at first, and then the tutor's like, no, 3 squared. And the girl wrote, she knew something was up with the 2, so she erased the 2 and just wrote a little smaller. So it was still 32 with just a little smaller 2. And the tutor's like, no, 3 squared, and just kept proceeding to repeat 3 squared over and over. And the girl just knew something with the 2. It just kept moving all over the different places. And she never really it went to like 3 sub 2, and she never really moved it up to the superscript. So here you could just say 3 squared. And you can get that notational component, be like, oh yeah, that 2 goes up in the superscript. And so you can then insert that in. And it's just another way as well. If you don't know how to go up into the superscript, you could easily just say that as 3 squared or 3 to the power 4. And so that gives you another way to say it, and we can represent those. So you might be like, oh yeah, 3 to the power 4 is the same way as putting 4 up in the superscript of 3 as the base. And so the speech component lets you start with the terminology and get the notation component out of that. So it's another great way to connect that learning component to representing it digitally. And all of that is like a much faster workflow than being able to physically write it down. So giving the students the choice to be able to create their math however they want, but I think also more importantly, to be able to consume it in the method they want is a really powerful learning mechanism for them to be able to create that fluency from procedural and all fluency for working their steps and to do a variety of things. And the same part, so you can do your prediction over here, so you can do a multimodal approach. If I had that 3x minus 14 equals 10 problem, and once I start my next step, so if I hit Shift Enter to create multiple lines, I can then work from my speech input. So I could say 3x minus 14 plus 14 equals 10 plus 14. Next step, 3x equals 24. Next step, x equals 8. And so literally I can do a speech dictation of what I want that solution to be, and it'll typeset that in there. And so I think that's another powerful component to be able to go from that spoken solution to a digital solution in that sense. Again, really great way to take my preferred method of communication and be able to digitize that. And now my teacher or someone on the other end can consume that. So I just went from speech. Now it's accessible, so it can be read aloud, and it can also be editable as well. So I can pop that back open and say, oh, like my teacher's like, we didn't show enough steps here. I can do Shift Control Enter and be like, oh, I wanted to do that over 3. So that way you knew that I divided by 3, and they can insert that back in there. So again, a great way to empower students to be able to communicate in the method that they prefer and not the method that I prefer, which as I became a more experienced teacher, I would not only realize my first few years, I only taught in the method that I learned because that was my default. And as I got more experienced, I could teach in methods that weren't my preferred way to learn. So I was able to broaden my scope of the ways that I could connect with students. Because my early years as a teacher, I'd easily connect with students who learned in the same way I did. It was reaching those students who learned in other ways than I did, or had different ways, different perspectives, which are awesome. And usually they would think they were wrong because they didn't do it like I did. So that's why I think some of the power of that digital piece is if I would do, I really liked working with a Google Slides presentation. And so I could do a collaborative slide deck for students. So one of the things that I would do is I would say, go ahead, I'll do a prompt here where I don't like the title. There we go. So Equatio is really cool. It works in the entire G Suite. So I just pop it up, same user experience, same things that I want to do here. And I would say something like, let's do speech input of ax squared. There we go. I want that x. So maybe I do ax squared. I can draw, and you can see we do some of the prediction there. It thinks I'm doing an axis of symmetry. But if I click over here in my graph editor, now it'll take what I had spoken and say like, hey, do you want to add a slider? And I can say, yeah. So I can then insert that graph. And I might give a prompt to my students so it's working on that, automatically inserting that. So now I might tell my students to take, let's, there you go. That gives them that ability to be able to see that graph, and I can then talk about it like I would want to. But also, I would tell them to make a copy of this slide and communicate on there. So I might say, give them a prompt and say, show when the graph has a. So you can see there, our discoverability says like, hey, there's some Equatio editable stuff in there. Go ahead and use Equatio to make your response. So I might say something like, show a quadratic where the y-intercept is 4. And so I would tell them to make a copy of this slide. So they would make their own copy. So each of them would duplicate. I'd tell them to put their name on it. So if I have a class of 30, I'd have 30 different slides. They'd each be working on it. They each have their own explanation that they could do and their own thought process. So it's like think, pair, share, or that like small grouping environment on a larger scale. And so then what they could do is they could just literally click on edit. It brings the graph back out, and they could use this slider, and they could talk about what happens as A gets bigger. And so then they might, also this is what I talked about with Desmos, shifting my teaching method. I used to teach quadratics. It took me about 2 weeks to talk about what A looks like. That's the concavity of that quadratic. And now I can show students who have no idea how to graph a quadratic, because we used to spend a week graphing and figuring out like how to plot points in the quadratic using an XY table, which again are really valid technical components, but they're not prerequisites anymore. I can say, what do you notice in this graph? What's going on there? And they'll be able to verbally tell me about it getting wider or shrinking. And then they'll notice like the main component for A, it shifts whenever it goes from positive to negative. So I can talk to a room full of people who had no idea what this is, and almost all of them will be able to be like, whoa, something happened right there. And then we can talk about like what's going on and what does that look like versus what this looks like. And they'll be able to come up with a conjecture about what they think. And that's really a way to have that discovery of learning. So I love this visualization bit. And so on this, what I would say is from here, I could put in a B and do a slider and say like, oh, what B does. And then they might talk about like, oh, if I want that y-intercept of 4, they can insert that in there. So they can really take that component and then drop it in there to display their knowledge. So I think that's a really great piece for from a learning standpoint and process, how I can have that group work so I can see multiple students, how they think about the problem. And we can have that really great sharing bit. So that's how technology, I think, enhances my stuff, enhances my lessons. Let's see, I know I've been talking. I know that I talk really fast, and I feel like I had to make up for that time that I missed. So it's even faster talking, and I get really excited about and passionate about the math, which makes me talk faster. So I apologize there. So I'll try to slow down a little bit here and see, maybe is there a question that we should answer, Greg, or do you want me to just keep powering through and we can
I'll have a look, just keep powering through it at the moment, but we'll come at the end. We'll kind of have a few questions for you, John. But look, I just love it. I'm learning so much new stuff that I haven't even thought I could do with Equatio. So yeah.
Awesome. Cool. I want to show a couple bits, then I'll fire through then. So I think one of the bits that I wanted to talk about is Equatio Mobile. And so Equatio Mobile, it's just I could use it. So this came about like I don't have a touchscreen here on my Mac. I have a touchscreen Chromebook, so the handwriting recognition works really well. But but most of my students don't have touch devices for Chromebooks or Macs, but they do in their pockets most likely. If you have an iPad or an iPhone or an Android phone, those are touch devices. So we created Equatio Mobile, which is just a URL. You go to m.equate.io, and it will show you where you have Equatio open. So I have it open in this Google Doc. And so now this is like an extension of my cursor. So here I could use my phone as another device, or I can even take a picture. And so what I could do is, here I wrote down a piece of paper, and we'll see how it goes. My handwriting is not really good, and you'll get to see a quick picture of me here in the morning. So I can use my device camera, so that's me. And I can write down a piece of paper. I can literally just take this picture, and then so now I can say like, yeah, I want to take this, and I want to save that as an image, and then just fire this into that Google Doc. And so you'll see here in the Google Doc, what it'll do is wherever my cursor is, see it blinking there under the 3 square, it's going to insert that picture of my math. So it's a great way for me to capture that physical learning and put it into the digital environment. Great for collaboration and all these different components. Seems like maybe my internet is a little bit slowed. Maybe too many people are watching cat videos here in Ireland early in the morning. But so it should fire in that image as I go. Let's see. It usually, maybe I'll make it a little smaller so it's not as big of a picture. And so there we go. So I can save that as an image, and it'll let me fire that in to wherever my cursor is in Google Docs or Google Slides, or even as a Google Form response or in a PDF. So anywhere I am, it can take that physical math and make it into a digital component.
Hey, John, just while you're waiting for that to come, there was a quick question. Someone just was asking about, is what you've just done previously and also using this mobile version, is that available if you're working in Microsoft Word, for instance?
Yes, exactly. Here on my Mac, if I opened up Word, it would probably take a while to open up because my things closed down. But the same process goes if you use Equatio Desktop. This is on my Mac. This is Equatio Desktop. If I opened it up, it would give me that same toolbar here on the bottom that's always open. And it allows me, instead of inserting into Google Docs, I would insert into Microsoft Word. So all those methods would still work, and I'll let it open up in the background.
Including the mobile you were just showing us in as well.
Including the mobile. So when that Word, you can see Word's opening up. If I open up that Equatio, it would give me my Microsoft Word doc here as an option to say like, hey, do you want to insert that into that Word document? Let's see, did it magically come in? It didn't want to go in there. I don't know why not. We'll see. Maybe there's a little bit slower. One of the things that it could try to do as well, I can try to figure out what that math is. Not a great picture, low light, front facing camera, but it does a really pretty good job there. My handwriting, I thought that 24 was a 2244. So I can do that same thing. I can take that and insert that. I chose my Google slide here as a difference. So it literally took my physical math, plopped it in there as it took that physical math, made it digital, and now it's editable as well. So I could change my active document. Maybe it had something to do with my doc. We'll see there. I can try it here in the Google Doc. It'll try to save that math again, and then if I take that and fire it in, it should make that into my Google Doc. But maybe, like we just saw, that it doesn't want to go into my doc.
It's far too early in Ireland, obviously. So that's cool. That means that if, say, as in a classroom with a whiteboard, if the teacher had to put that up on the whiteboard in handwriting, the students, if they have a mobile device, they can literally take a photo of that, grab that, convert it into digital math, and dump it in whatever, a Google Doc or a Microsoft Word document, whatever they've got open, and they're good to go.
Totally, yeah. And that's the really cool piece, is it's almost like instant accessibility as well, because everything we do, we create the spoken math, so they can go from like something on a piece of paper or physical math and then create that accessibility aspect there. So I think that's really cool. Just to highlight, you can see I have Equatio Desktop open down here. There is one small thing, we don't have the Equatio MathSpace component that directly links there. That's fine, you can download that Equatio MathSpace, but if I have this as the Word bit, now when I go back to my Equatio Mobile, it should have let's see if I close that down. It should have that as an active document if everything worked like we wanted it to. No, it didn't. I'm having trouble with Word. Maybe it doesn't know that I can insert there. Let's just check that it's inserting. It should. Another cool thing about Equatio Desktop is I can copy it as a variety of things. I can get the images, or I can copy MathML, which if I copy the MathML and then paste it in, it makes it as a a Microsoft equation type. So that's a really cool thing.
Okay.
Yeah, that I'll close that out. It doesn't look like it wants to work. It's more of a Word thing. My Word was crashing when I tried to restart my computer. It would show up there. It would have a little. It would actually have a Mac thing and say my Microsoft Word document. Yeah, so Equatio Mobile works in Word as well.
We've only got a few minutes left, but you're going to show us in Google Forms?
I am as well. Yeah, so here as a teacher, I can make it in Google Forms, but also the students can answer here. So I can click that up. Equatio Mobile works here too. So now if I'm in Equatio Mobile, it knows that, hey, do you want to put an answer in? So I can do the same thing here. I can, we'll assume that's what I want to put down. I can save that as an image and just submit that, which is really cool because it's a way to submit the physical math into the digital realm, because I want my submissions to come through Google Forms. That'll try to auto grade it. It won't, because it doesn't auto grade the picture, so it'll tell me that I didn't get it right. But I can also try to do that if I recognize it. It'll do the same thing. So I think that's a powerful bit to let the students, they could respond to Equatio in a variety of ways. Like here, if I did the speech input, I could pop over here and say 3x minus 10 equals 14. Next step, 3x equals 24. Next step, x equals 8. And so I can kind of give a verbal response there. It inserts that math as my form response, and it gives me that ability to create my response however I want to. Let's see, there we go. It should insert. And so once I submit that as well, like that, I can see from here, it'll give me some solution. So I can say like what I wanted on there as a teacher, and I can see all those responses come in. So that's a really powerful way for instant formative assessment, instant way for me to see what my students are. Do they understand? What is their answer going to be? So I love using forms for that to inform my instruction, that formative piece. I can say, are they ready to move on? Or I can use it as a summative piece by looking at the response spreadsheet. And then I like to work here. I can see like all my students' work. Some are physical. Some might do more steps in there. So the first time it pops open, it'll have this Equatio URL. You'll see here my lightest ones would just be a URL. You can see this one, that one I did a handwriting bit, but here all I have to do is click on the Equatio icon, and it'll magically turn these into the images I want. It'll do that the first time, and then after that, that just says like, hey, I want to turn all these things into pictures, and it does. So now I can easily see all those in my worksheet, in my spreadsheet, and I can give a quick verbal response. I like this from a feedback standpoint because I usually have the same few comments, so I can copy and paste those comments and give feedback faster using like a mail merge or some other way that I would work from a spreadsheet. I'm going to do one more thing, Greg. I'm going to talk about the not plan. I think that's how you say it, but I love that on the website that in the booklet they use Equatio Blue for this. This is TextHelp's PDF reader, so I opened this up in a PDF reader, and Equatio works here. I just pop open on my toolbar, click Equatio, it works, and then here one of the really cool parts is like the speech, the screenshot reader. So I can literally, we'll see if this works. I should have tested this specific one out, but maybe they need that to be read aloud. It'll try to do that and read that aloud from the text and also the math that might be embedded in there. So it tries to figure out what that is. Ryan is making a calendar period. Line 2, 3rd of June is a Friday period. Line 3, 1. So I don't know if you could hear that as well, but it was reading that aloud.
Very faint, yeah, but we get it, yeah.
And so some of the good parts is I can do that same part if I want to, like say I want to use this part, I can do any of these parts of that math. So I might say something like 6 plus 10 plus 4 equals 20. And if I do that insert bit, it allows me to just drop that straight onto that PDF. So this is a normal PDF. I literally took this from the Not Plan website. And I can just do that math directly on there. So that for me, I think is a really cool way that I can process that. And I could say if I want to do that like 6 out of 20. And so I can work however I want to make that process directly on a PDF. And I can have it be read aloud if I want as well. So it'll read the math out within there. Yeah, so that's kind of all the different ways that we could use it. I didn't talk about the Equatio Math Space. That just launches open to our really digital whiteboard where I have all these accessible bits of Equatio, but I also have like some smart shapes. So one of the shapes that I could do here, I might want to talk about like a fraction bar, so I can talk about tenths, and I can make that. And so there's some really cool things on here. I can do a grid if I want to make that like a 1 by 10. It'll do that in tenths, and so I could, talk about different shapes and how those both represent tenths and how I can represent things. And then if I want to insert it, I just click this button and it'll take that whole component and paste it into wherever I am. So that's like the same thing. It's a picture, and so I can put that wherever I want, and I can do all those math bits and embed them in a PDF or in the Google Suite or in Microsoft Word. Really, wherever you want to create your math, we can make it easy to do that. You want to see, do we have any more questions there, Greg?
Oh yeah, John, I'll have a look. I know that some folks were just wondering, when you get Equatio, do you only get one platform? If I do I only get access to, I have to get Equatio for all the platforms, or how does that work? How do I get Equatio?
Yeah, so essentially you get Equatio. It's like Netflix. Netflix doesn't care if you're watching it on your iPad or on your computer, whatever. It's the same thing. We don't care where you're using Equatio. So you get an Equatio license. It includes all the platforms. The sole thing that I didn't talk about it, we have an LMS integration for Canvas. And so if you're a higher ed institution and you want to use that, then there's an extra price. But essentially, if you want to get Equatio, the cool part is you can just go to the Chrome extension, you can install it. And so it's the word equation without an N at the end of it. And you just go there and you install it. It would say add to Chrome. I have it in here, so it says remove. And then you can install it. And when you first install it, you get all the premium features for 30 days. And then after that, it will revert to the free license, which the free license essentially works in Google Docs and does some of the things. So if you want to use all the Google integrations, you need to have the premium license for that bit.
Okay.
But you can,
and John, yeah. So I was just going to jump in again to say, so that it's full of stuff. But what's been the newest feature that's been added just recently? It was.
Yeah, so I think one of the newest feature that we've had was if you go into your options menu, you can change your languages. And so we have the UK, which also encompasses Australia, New Zealand, but you can do Spanish and French. So we have the French localization, so you can speak in French, everything turns into French. So that's one of the newest bits that we have.
Yeah.
And some of the things that we've been really working on is adding different types of shapes. So you'll see we have a big Pi Day launch coming here for the shapes that are in this Equatio math space. And so I'm really excited about that. We're even adding currencies. I had a demo up the show before I restarted, but I lost it. And I have to jump on the VPN and stuff to get it out. But essentially we have currencies. We have the Australian and New Zealand currencies that you'll be able to drop in.
Wow.
Some tens frames, pentominoes, base 10 blocks, just really a lot of different more manipulatives that really work well for younger students. And some of the other bits is that multiple lines environment allowed us to do other things with prediction. So we have things like if I wanted to do like addition, I can do like a 2-digit vertical addition, and now it makes it easier, like it prompts them so they can line those up so they can do that math. So I can insert that and have my students edit that so they can then use speech if they want. So they can drop here and they can do the handwriting. So they could say to, and they could work and say that's 9. And then here they could say that's 7. So we made that environment able to have students work, or they could do the same thing. They could say 7. And so it makes it easier for younger students. My daughter's 5, and so I always have her working around with her math bit. My wife's a math teacher as well. So we do a lot of math stuff. And so I want to make it easy and intuitive for her to be able to do it so that we're adding a lot of younger features. And if younger students can work on it, then older students can as well. So it's kind of like my goal is to make really my daughter to be able to easily communicate her math bits. And so we have a lot of younger structures. And then we just put in the most recent update, a lot of different predictions like the speed of light, so a lot of physics references. There's so many formulas in here. If I wanted to talk about the quadratic formula, there's a unit that I teach that, but after that, it's a reference. So it should make it really easy for students to use that.
Yeah.
And even in we have calculus bits, so we have some higher end stuff going in there. Matrices. So if I want to do like a 3x3 matrix with braces on there, they can do that. And they can even use, like really complicated higher level stuff if they want. So we can really do a lot of things that if you want, we can do the math copy, we can do the notational representation. So the next things we're doing is working on bringing more shapes in there. And so leave us feedback if you want through this, every Equatio thing says send feedback, goes to a Google form that I read, and we really take that into consideration and how teachers can use it more effectively with students.
That's great. That feedback thing is designing, is actually making sure Equatio is what's needed by teachers and students. Hey, if you were to give one key thing, starting the school here in Australia and New Zealand, we're starting the new school year, and we've got Equatio. What's one or two things that you would say are really key to making a great start to the school year with Equatio?
I would say the first thing that I encounter so many math teachers with, and this is myself, is that I always felt like I had to have all the answers. And as I evolved as a teacher, I really enjoyed the whole I don't know part. And I feel like so many math teachers feel like they should have all the answers and should be awesome at technology. So the first thing I would say is like, don't be afraid to embrace asking your colleagues. It was really humbling for me to ask my English teacher next to me for tech advice, because I was like, oh, that's a chink in my armor. I should be able to do everything. And so
Yeah,
asking them for help, but really the more power is to show my students, like, I'm not really sure how to use this tool. I think it's really powerful. Let's explore this together. And then the students will find really creative ways that they prefer to use it, and they'll get that
yeah,
engagement. And once
yeah,
they're engaged, that's when that learning can happen. And so
yeah.
I think that's a powerful bit.
And
Um,
that's an idea of learner agency, isn't it? We can give it to the students, and they'll drive it really.
right.
Um,
And then I think that also does help with the almost virality, is like they'll see that they can, it's powerful for them to use and how helpful it is. And then I would say, like, from an integration standpoint, like take a PDF that you already have and just use it. Like that's a really, I don't want to say low bar, but it's like low transition. You don't have to learn a bunch of new things. You can just take a PDF that you've scanned from the copier and work with that. And then I love the self-grading Google Forms are really good to be able to do that. So I think
yeah.
those are really powerful ways to save my time as a teacher, because that's our most valuable commodity.
Hey, cool. Hey, I've got one other question. This just came in, just going back to the Australian and New Zealand currency. Any idea when that'll become available in Equatio?
Yeah, so we're planning for a Pi Day launch. So Pi Day 3/14 is March 14th here, and so we're planning on a launch around centric around Pi Day. So it should be in about
Uh,
2 weeks, a little 2.5 weeks.
so we need to be ready for Pi Day.
Yeah, exactly. Pizza pie, apple pie, like any type of pie, and you could do that. I'm more of a Tau man myself, but generally in North American calendar, Tau, which is double, it's 6.28 or like 2 pi.
Yeah.
We usually don't have school on that day, so I can't celebrate Tau Day. But so we go for the Pi Day part. But I'm on Team Tau if there's a Team Pi or Team Tau battle, and I have lots of mathematical reasons why I support that versus Pi. But Pi has become the powerful leader here.